theorem. The factor theorem, we're going to talk about the rational zero theorem too, but we're going to start with the factor theorem. The factor theorem says the number c is a zero of a polynomial function y equals p of x if and only if x minus c is a factor of that polynomial. Yesterday we talked about dividing. We said we'll take a polynomial and divide it by like x minus 3. Its remainder would be the solution of plugging that value in. Well, today we're going to do the same thing. We're going to divide, but now we're looking for things that the remainder will be 0. If the remainder ends up being 0, that means that particular equation, in this case it's x minus c, goes into it evenly, so you get an even number out. It's kind of like 6 divided by 3 goes in evenly because it comes out as 2. So you can rewrite 6 as 3 times 2. You are factoring out a 3. So today we're going to talk about how do I factor out something like x minus 2? How do I factor out like an x minus 3? Because up until today, let's go ahead and look at this next problem, there wasn't much we could do with x cubed minus 13x plus 12. Because we haven't talked about factoring something to the third power. The quadratic formula does not work for something to the third power. You cannot complete the square for something to the third power. So we really have no way to solve this right now if I set that equal to 0. However, today we're going to talk about how can I factor out something so I can turn it into a quadrilateral, something I can put into the quadratic formula, something I can complete the square, something I can factor further. So that's what we're doing today. So what we're starting off with is x plus 4 a factor of x cubed minus 3x plus 12? In other words, can I pull that out and have x plus 4 times, say, x squared minus bx plus c? Can I rewrite it that way? So the first thing you're going to do is you're going to check to see if x plus 4 is a factor. Yeah. Oh, well. Okay. Solve that problem. In the act of checking it, though, we're actually going to be able to factor it out in one step. So we do still have to go to the work, even though we know it is because Emma said yes. So when I'm looking at x plus 4 being a factor, what I'm actually looking at is, if you remember, I'm actually looking for what happens when I plug in p of negative 4. And we are going to use synthetic division. We can use regular division too, and we'll get the exact same answer. So if you like regular division, go ahead and do it. If you forgot that synthetic division, you have to go with the x turning this into 0. You forget that, just do regular division, it will work. I'm going to go ahead and use synthetic division. All right, with synthetic division, I want to account for everything. So I have to account for my coefficient in front of x cubed. I need to do the coefficient in front of x squared, x, and I have to list my constant. Well, the number in front of x cubed is 1. The number in front of x squared is, well, 0. The one in front of x is negative 13, and my constant is 12. All right, for synthetic division, the first thing you do is you drop down that first number, which is 1. Then we take our negative 4, we multiply it by 1. Negative 4 times 1 is a negative 4. Then we go ahead and add that. 0 plus a negative 4 is a negative 4. Then we do 4 times this ugly green color. Negative 4 times negative 4 is a positive. Isn't it ugly?
That's like really gross.
Yeah. I'm going to stick with it, though.
All I see is like black gold.
It's like brown. Are you actually?
Yeah, I see brown.
It's green to me. All right. Negative 13 plus 16 is going to be 3. And finally, when we do our negative 4 times our 3, that's negative 12. That comes out to 0. What that 0 means, it means two different things. It means basically, we have, So p of 3, p of negative 4, I was looking at the wrong one, equals 0. It also means that x plus 4 is a factor. Which is kind of a huge deal, because now what I can do is I can rewrite x cubed minus 13x plus 12 as a factor of two things. I factored out x plus 4. And so now I can have it as x plus 4 times something. Does anyone know what goes in that something? What goes in that something? Emma.
X squared minus 4x minus 3.
Yeah. We're going to do x squared minus 4x plus c. And that comes from our quotient. This is your quotient. Just like 6 divided by 2 equals 3, we'd write it as 2 times 3. This is your quotient. And remember, it's 1 power less. So this would be 1x squared, negative 4x, with a constant of 3. So I just rewrite my quotient right here. So x cubed minus 13x plus 12 equals x plus 4, because we proved it can factor out, times x squared minus 4x plus, not c, but 3. Well, 3 and c rhyme, so it's kind of the same answer.
It is the well, like, if you just go like, then it's the same thing.
Okay, let me finish this and we'll go to questions.
Actually,
All right, so here's the thing. Now we have x squared, guys. Now we have x squared minus 4x plus 3. That means we can factor it, we can complete the square, or we can put in the quadratic formula. Well, it is factorable, so we can have x plus 4 times x, actually it's minus 3 times x minus 2. That is a fully factored form of x cubed minus 13x plus 12. So we'd have a 0 at negative 4. Already knew that.
why would we want
Oh, yeah, that little guy. No, it would be a negative, because negative 3 times a negative 1 is a positive 3, and negative 3 plus the negative 1 equals that negative 4. So that is correct. So our zeros would be negative 4, 3, and 1. Mark.
If there was a remainder, would you do x?
You can't use it.
Oh,
So if it's not factorable, you cannot use it to rewrite it.
okay.
Because you can't pull it out, because you'd have to put like remainder 2, which doesn't help you solve for zeros. All right?
Yep.
What it means to be a factor is not only is it a factor, it's a 0. And so you actually know one of your zeros, and we use the rest of factoring or completing the square to come up with our other zeros or quadratic formula. All right, any questions on that? Okay, the next thing we're going to talk about is something called the rational zero theorem. So if I factor 6x squared minus x minus 35 equals 0, I can factor that into 2x minus 5, 3x plus 4 equals 0. Well, that gives us two zeros, 5 over 2 and 7 over 3. I'm not too worried about the negatives right now. What I want you to notice is our constant is 35. Note that 35 is divisible by 5 and 7. Our leading coefficient is 6. That is divisible by 2 and 3. What the rational root theorem says, if p of x is a polynomial function with integral coefficients with leading coefficient and constant term is not 0, and p divided by q is a rational 0 of p of x, then p is a factor of the constant term and q is the factor of the leading coefficient. Nailed it. All right, what that means, in short, is if your 0 is rational, that means you can turn it into a fraction. If your answer, or if your 0 is rational, the numerator of your rational 0 will be a factor of your constant. So that'll be a factor of the constant. So in this case, it would be a factor of 35. So that could be 1, 5, 7, 35. Those are 4 possibilities on our numerator. Once again, if it's a rational 0, our denominator would be a factor of our lead coefficient. So what does this help us do? Well, if we have a big, long equation that we don't know how to solve, we can use the rational zero theorem to narrow down what possible rational solutions can be. It's not going to list which ones are your actual zeros, but it'll narrow your list from infinity down to a much smaller thing that we can just test and check to see if it works. So let's look at what that looks like on the next page. I need to find all zeros of the polynomial function 3x cubed minus 8x squared minus 8x plus 8. On, I believe, Friday, we'll learn how to factor that if it's factorable. But for today, we have a cube, so we can't use the quadratic formula. We haven't learned how to factor it. We can't use complete the square. So what we can do is we can narrow down from testing every possible number across the board to just narrowing it down to, I think it's like 16 possible. So what we are going to do is we're going to find the factors of our constant. So that 8 right there is this 8 here. So we're going to find the factors of 8. Well, our factors of 8 are 1, 2, 4, and 8. Note that's positive and negative. Negative 1 goes into 8, and so does positive 8, but we'll see that on the back end over here. All right, then let's talk about the factors of 3. That'll be 1 and 3, positive and negative. Well, according to the rational theorem, the rational root theorem, if this has a rational 0 in it, one of these numbers will be in the numerator, and one of these numbers will be in the denominator. So we can narrow all of our zeros down to just these possible. This is just for rational. It could still have a square root that doesn't show up. It could have an imaginary number that doesn't show up. Ross? It is from that 3x cubed. Sorry, I should probably do that. That's our lead coefficient. So that 3 came from that guy right there. Boop. All right, so what we're going to do is we're going to take 1, 2, 4, and 8 and put it on top of 1, which will look like the fractions 1 over 1, 2 over 1, 4 over 1, and 8 over 1. Then our next one is a 3, so we'll go 1 over 3. We'll go 2 over 3. We'll go 4 over 3.
Does it have to be plus or minus?
And then we'll go 8 over 3. Now to tackle the plus or minus, just throw plus or minus on the outside. Or you could put all your pluses and minuses in front of all those numbers. Your choice. Okay, so these are all of our possibilities. So we started off with any rational number might work for this. 2, 1, 2, 3, 4, 5, 6, 7, 8 times 2. We have 16 possible. We have positive and negative 1, positive and negative 2, positive and negative 4, positive and negative 8, positive and negative... you get the idea.
Yeah.
Now we have to check to see if any of them work.
Yeah.
So now what we have to do is we have to either plug each of these into this equation and see if it comes out as 0, or we can use synthetic division. Let's start with a positive 1. Let's use synthetic division and a positive 1. So with synthetic division, we'd have 3x cubed minus 8x squared minus 8 plus 8. Synthetic division is drop your first term, multiply it by that 1. So we have 1 times 3, which is 3. Negative 8 plus 3 is negative 5. Thank you. We have 1 times negative 5, which is negative 5, which is negative 13. It doesn't look good. We have negative 13. It turns out it's negative 5.
No.
It is not a factor.
That's sad.
Now we try negative 1. We try negative... No, we're not going to try all of them. Instead, we're going to go, hey, I have this nifty little thing that is my calculator.
Yo.
So if you didn't have your calculator, you'd have to continue checking. So that's what that dot dot is, continue checking.
You have to check for?
You have to make sure the remainder gets to 0.
You have to find one that has a remainder of 0.
Oh, which one did we just do? Did we just
We tried positive 1. That's all we tried.
1 over 1?
And then we quit.
It's 3.
And then we quit. Okay.
We're quitters.
So if I said you can't use your calculator at all, you'd have to do 1, negative 1. You'd have to do 2, negative 2, 3, negative 3, 8, negative 8. Not 3, negative 3. Yeah. I wasn't looking at the time. All right. But if we continue and we open up our Wabbit calculators, and we are going to go to our y equals, and we're going to make sure none of our plots are highlighted. And we're also going to make sure it says y equals and not r equals. If it says r equals, that means you haven't pulled out your calculator since before. Yeah, that'd be first mark period, I think. All right. There are people that still have r equals. But we're going to type in 3x cubed minus 8x squared minus 8x plus 8. We're plugging in what it says.
Where's the X cube button?
There is no x cube button, so what you're going to do is you're going to hit the little caret button.
Oopsie.
Oh,
Where?
I'm pointing to it. I'm literally up here pointing at it.
Under clear.
If you look here.
It's the squared. It's squared.
There's also a cube one under your math button. But let's get this in so we can go ahead and hit graph. As soon as you get it, let's go ahead and hit graph.
I got blank graph.
Me too.
Then hit zoom standard.
I got an N for
Hit.
It worked.
Yay.
I got it.
All right, everyone.
When did what?
I'm not there yet.
Sad.
Typing it.
Did we hit zoom standard?
Wait.
No.
Zoom.
Wait, enter.
That did it.
Graph.
There you go. There's the
It's
end.
not there.
Okay, zoom standard.
Oh, wait, no, I hit something.
Once again, hit zoom standard.
It's
Oh,
there.
do you usually go where equals 0?
There.
Are we good?
Yes, we're fantastic.
All right. Now we're going to look at this graph and compare it to our possible zeros. Let's look over here. This looks like negative 1.1, negative 1.2, something like that. I look at my possible zeros. My possible negative zeros are negative 1, negative 2, negative 4, negative 8, negative 1/3, negative 2/3, negative 4/3. That could potentially be 4/3. But if you think about 4/3, it'd probably be a little further. Well, let's go over here.
Okay.
Oh.
This looks like it's about
1/2.
4/3.
2/3.
1/2 or 2/3. Do we have a 1/2 or a 2/3 up there?
2/3.
We have a 2/3, so let's try that one. Let's try positive 2/3. This isn't foolproof right now. We'll find a way to use our calculator to find all our zeros, but for right now, we're saying 2/3 might work. So let's check 2/3.
You should check it on paper.
Yes.
I was just wondering.
Especially if you're pretty confident, because you are actually factoring it out then. All right, so we are doing 3, negative 8, negative 8, and 8. Carry down that 3. 3 times 2/3 is 6/3, which is 2. Then we have negative 6. Negative 6 times 2/3 is negative 12/3, which is a negative 4. Negative 4 times 2/3. Oh, I'm sorry, negative 12. Negative 12 times 2/3 is negative 24 divided by 3, which is a negative 8. 8 minus 8 is 0.
Yeah.
Do we only have to write one of the ones that work?
Yeah.
Is there only one that works all the time?
No. That just means we have one for sure rational. We'll see what we're going to do with it in just a second. But you generally only have to do it once. Sometimes you can do it more times if you want to. All right. So we have, in this case, this was f of x. So that means f of 2/3 equals 0. And 2/3 is really x minus 2/3. So I factored out x minus 2/3, and my quotient was 3x squared minus 6x plus negative 12. So not only did I know it factors out, I actually know how I can rewrite it. I can rewrite it as x minus 2/3 times quantity 3x squared minus 6x minus 12. So let's go ahead and do that under the factor and solve. So what we just did, let me write it all out. So we started with 3x cubed minus 8x squared minus 8x plus 8. And we factored out an x minus 2 over 3, which resulted in a quotient of 3x squared minus 6x minus 12. We know 1 0. It says find all the zeros. We know one of them. One of our zeros is 2/3. Now we just need to find the other two. So what we're going to do is we're going to set this equal to 0. So we'll have x minus 2 over 3 times 3x squared minus 6x minus 12 equals 0. Either x minus 2 over 3 equals 0. If that's the case, x equals 2 over 3. But we already knew that. We checked if 2 over 3 was a 0, and it was a 0. Our other possibility using the zero product property is that 3x squared minus 6x minus 12 equals 0. That's where my other two zeros are. Well, if I have 3x squared minus 6x minus 12, before I look at factoring or anything like that, what would probably a good first step be in that one? Natasha? Take out a 3.
Oh.
Divide everything by
Before
3.
factor, but I was going to say factor of 3.
Oh, okay, fair enough.
Can you wait, so you can divide by
I'm going to divide by 3 because it's still balanced. It's both sides by 3, so that's going to leave us with just an x squared minus 2x minus 4 equals 0. It's not factorable. It's not factorable, but we have two other things. We can complete the square, or we can put in the quadratic formula. We're going to go ahead and complete the square because we just did it to complete. This is going to be on your test. Completing the square is on your test because you have to put it in vertex form. So let's complete the square. That involves moving the 4 to the other side. And I'm going to add negative 2 over 2 squared to both sides. Here is my question for you. When we're doing vertex form, I add it and then I subtract it. Why am I adding it to both sides this time? Why am I not adding and then subtracting? Priya? Because they're on different sides. Adding to both sides keeps it balanced. If I can only work on one side, remember with vertex form we had a y in the zeros place, I couldn't work on both sides. That's when I had to add and then subtract. So we just need to add that to both sides. Our next step is carry down the x, carry down the negative 2 over 2, which is negative 1, squared, equals 4 plus really 1, which is 5. Take the square root of both sides. We're going to have x minus 1 equals plus or minus the square root of 5. Our answer is going to be x equals plus 1 plus or minus the square root of 5. Note 1 plus or minus square root of 5 is not rational, so it would not fall under this umbrella.
Oh.
It has to be one of our rational zeros. So don't think just because it's a 0, it's going to be one of these numbers. Irrational numbers are not going to be under that rational 0 property. Yes?
So which answer are we looking for?
All three of them. It says find all zeros.
What was the other one besides 2/3?
So we have x equals 2/3. We have x equals 1 plus or minus square root of 5. You can group them all together into one answer, or you can just circle where you have the answers. 1, 2, 3. 1 plus square root of 5, 1 minus square root of 5. And if you look at your graph, you have 3 zeros. This accounts for all 3 of them.
Okay.
Emma. Mary.
Can you go over how to do that in calculator again, please?
Sure. Which part?
I don't feel like why you can tell me the right there starting here is a phone battery.
Did it graph it? Oh, hit graph. Hit zoom standard. Your first few are pretty easy. They're just checking to see, 31 and 33 are just checking to see if it's a factor. 35 through 41 are seeing if there's zeros. It's the same process. You are checking to see if your remainder comes out 0. On 51 through 65 is what we just did in class. You're going to come up with your potential zeros, use your calculator to approximate which one you think is your rational zero, and factor it out and factor down to something, come up with all your zeros. Sure, why not?
What? There's like 7. Wait,
Remember, your answers can have imaginary numbers, but they will all have a rational that work for it.
is the last one just
The last one is just look at the graph. Plug it in your calculator and just look at your graph and come up with answers from your graph. I'm not asking you to list all your potential zeros. I just want you to look at your graph and come up with where it equals 0 based upon what it looks like. Safa.
The number 35 and factor, are you plugging in or are you dividing?
Number 35, you were going to use synthetic division. So try to use synthetic division. Keep with what we're doing. All right. So when I ask is 3 a 0 of it, I'm really asking you is x minus 3 factorable. You should think of it, from now on, you should kind of think of it as being both things. When I plug in 3, I'm actually seeing if x minus 3 is a factor. Other questions on the homework? Yeah.
Well, this is kind of a specific
Okay.
question.
Yeah.
So, like,